Hi, welcome to this video. In this lecture, we're going to talk about text in data visualization. So it's important to mention that the background of most of our students from engineering, business, in the course that you took, typically the statistics courses, you learn how to handle numerical variables and even some categorical variables. But text was not common in your analysis. The tools that you learned in most of the cases, they didn't include the how to process data, how to analyze data, how to perform an exploratory data analysis if you have text, right? So it is important to be aware that around 80% up to 90% of the data worldwide is unstructured data. Unstructured data means that it's not data that is located in tables. Typically, you will find in unstructured data numerical variables or categorical variables, even text in some cases. However, unstructured data accounts for images, videos, and text. And it's most of the data that we have available. And this is increasing. So what happens is like our data scientists are really prepared to handle numerical variables, categorical variables, most of the times using structured data. But when you face text or other types of unstructured data, then you struggle a little bit more. So that's why we're gonna cover how to perform EDAs when you have text. With what is the purpose of this? Pretty much we want to find patterns, trends when we have text data. Uh, there are different models that exist, right, beyond the typical EDA. I'm sure that you have heard of sentiment analysis to analyze whether a customer or a review it's good or it's bad. We also have topic modeling to understand or to group. This is like clustering for text. So there are very common problems that have been solved for text. Okay, so the difference between structured data and unstructured data. We are familiar with structured data, tables, typically spreadsheets, when you use Excel. Uh, that's structured data. You have like one column, and each column is a variable, each row is an observation. In unstructured data, it's not that simple. You have nested tables. Our data can be like different formats, images, video, text. So it's more complex, right? Unstructured data. And as I mentioned before, the volume and the variety is higher in unstructured data, and text it's found mainly as unstructured data. Okay, so why it is important to learn some basics of text analytics? Well, this is important because there are a lot of applications from customer service analysis. Companies in general are really interested in understand what their customers are saying on the internet. That can be in social media, but also in some web pages where when the customer they leave a review. So if you want to automate, if you want to automatize like how to process all that information and get the insights. So you need text analytics for that. Uh, it's really common. For example, when you are gonna buy something at Amazon, in the past you were given like a rate, like number of stars for the product, and also the reviews were available, right? Still we have the same information, but now recently you can see like, okay, what is there is like some sort of text analytics where you get some insights, like a summary of the reviews. So if you read the description and before the reviews, you would say, okay, most of the customers are saying this and this, like the good things, or most of the customers are complaining about these other features of the product. So that's text analytics to help you, right, to make a decision. For when you're talking about spam detection, that's text analytics. When you want to summarize data, now that we are familiar with generative artificial intelligence, I'm pretty sure that in the last 3 years now people is way more aware of text analytics and natural language processing thanks to generative AI. because we use it right on a daily basis. So that interaction, uh, it's text analytics, it's natural language processing, NLP, NPL. All right, let's see why text visualizations are important. So first, because text has a lot of complexity, it's high dimensional. So we need to understand it, analyze it, reduce the complexity. Even when we summarize text, that's a dimensionality reduction technique for text, right? Of course, you cannot use here PCA or the same models that algorithms that we used in our previous classes. Okay, so thanks to the visualizations here, we can understand, okay, which words are frequent. We can also see some relationship between some words. The most common visualization techniques, I'm sure that you have seen word clouds, frequency plots, which are bar charts, the n-grams graphs, which we're going to learn right now, and even topic modeling visualizations. So these plots, they can be like classified, right? Some of them are for like statistical visualization, so it's more about the frequency. So word clouds, bar charts, they are like frequency-based plots. But also sometimes you wanna see the relationship of the words. So it's more like semantic and network visualization for this. These are very common when you wanna find a topic. It's not just about okay. We have a discussion about let's say about health issues in a specific country, but that's like the general topic. You want to know, like, okay, which specific topics or which specific things are people saying about health. So maybe it's the cost, the quality, the coverage, like there are different topics. So that's what you can find when you perform a topic model. All right, the knowledge graphs are also useful. Remember the network graphs that we covered in previous lectures. They are very useful when you are doing like a literature review or state of the art for a capstone project or thesis. It's very common that authors will perform, using some papers, books, the literature. They will create a network graph which will show, okay, what are like the keywords, like what are the most important words, concepts that are mentioned in the papers, or even for the authors also they show some networks to see, okay, what is the most important keyword, what are the most important authors also. So these are examples of text visualizations. If you want to analyze time or geographic location, then you can use maps for this time series to display this type of analysis. Some common metrics when we are trying to perform an EDA, an exploratory analysis for text. There are some volume metrics. That's very common when you're using like Microsoft Word. If you see like at the bottom of the document, it will count, okay, the number of words, number of characters. Those are some of the typical metrics to like perform a descriptive analysis. You can also compute like average word length, or you can not just focus on the volume, also in the context, in the vocabulary. So for example, unique word count, the lexical diversity. So that will give you an idea of the words that are being used. All right, so let's go over some of the plots that we're going to use for our EDA. Word clouds, they show frequency, like which words have a higher frequency. So the font size for a word in a word cloud will be given by the frequency. So the higher the frequency, that word appears in the document that you're analyzing, then of course the bigger will be the font size. So we can use this for, like if you're analyzing data from X or any other social media platform, you can use word clouds to represent that. If you have like a survey with open questions, then this is a good way to visualize your data. Bar charts, they also are useful for frequency word frequency plots. It is important that you transform, you clean your data. With text, let me tell you that the complexity is higher compared to numerical variables and even categorical variables. Because in text you have a lot of complexity, and variability. For example, some users will, some authors will use like uppercase letters, others will use only lowercase, special symbols, that hyphens, hashtags. So all those characters, the different even words that are alphabets. So that creates noise. So it is important. There is a lot of variability here. So before you analyze your text data, you need to clean the data. You need to remove some stop words because if I leave like the pronouns here, the prepositions, then if we create a word cloud, it will show, like the prepositions and the pronouns will be on top of the list. But the problem with that is that you don't get insights from that. So that's why we remove these words that are common, just connectors, the punctuation, just to avoid confusion in the analysis. This is not an easy task, even though there are a lot of libraries, commands, and it's simple to do the things that the variability that you will face here is higher. Even if you have like a good pipeline for cleaning your data, if the source text changes, you might experience some problems. Maybe there are some special cases that you didn't consider at the beginning, and that's normal, especially with text. It's not that simple compared to numerical data. The n-grams are really useful, like a bgram or 3 grams, because, okay, first step is to compute like the frequencies for a single word, but a single word is not enough. For example, the word good. Good, just by itself, it's not enough information, because what if you have the good for nothing in the comment? So it changes, of course, the whole meaning of the sentence. Then that's why we use bgrams, 3 grams, or n-grams in general. So the unigram is only a single word. Bgram when you have like two words together. So the frequency of the pair of words together. The 3 grams when the three are together. The only challenge here is like if you keep increasing the number of words together, then the frequency is going to decrease because it's less likely that they will appear in document. So that's going to depend a lot from the source file. Like if it's short text or it's a long text, then that's going to limit the n-grams that you can use. The network graphs that we mentioned before, this is for connect words and the relationships. It's to understand like, okay, which words are really important in a text. All right, so let's go to Colab. Let's use Python. Okay, so the most popular library here in Python, it's NLTK, this one. So it stands for Natural Language Toolkit, the Natural Language Toolkit. So it has a lot of methods to do the EDA, cleaning data, and also for modeling, for the sentiment analysis or topic modeling. You will find different options here in this library. Okay, so let's get started. Here we have a very short text. So our original text is just, it has six sentences or phrases. So text analytics is fascinating. They are in the same line, right? Now, as I mentioned before, we need to clean the data, prepare our text data. So the first step, that's what we call tokenize. We need to tokenize. So when we tokenize text, it means that we're going to split the sentences in words. So here we created a function to tokenize, and we use, of course, some methods that already exist in NLTK library. So what we're doing here pretty much is that we are removing, like special symbols. We're converting everything to lowercase. So we're trying to standardize the data. So let me show you how it looks. So our data frame is data. So this is the original text is here in the column text. So for example, this one is text analytics is fascinating. And we have a symbol here. So when we tokenize, please note that we remove here some words like is. we remove some connectors. So we just get these three words: text, analytics, and fascinating. So same thing with each phrase. So we tokenize it, right? This is the column where it's tokenized, and if you check the original and then the tokens, you will notice that yeah, we remove pronouns, we remove the prepositions, some connectors, and punctuation. So this is a required step to ensure that our EDA it's more meaningful. Okay, then we create our word frequency plot, which is it's a bar chart, pretty much, just to see the most common words, right? We're counting here. So let's see how it looks. In this specific example, the most common words are text, analytics, and data. So text has a frequency of 4. It appears 4 times in the original sentences. And then analytics and data both appear 3 times. The remaining words are only 1 time. This is the top 10. This is the top 10. With the same information, we can create a word cloud. So the word cloud first joins all the sentences, and then it creates the word cloud for the complete document. So again, the font size is given by the frequency, and it's not, you already knew that text is a higher frequency, then followed by analytics and data. All right, once we have created our bar charts, word clouds, remember the n-grams, right? The bgram, 3-gram. So the bgram here, we're using the n-grams function, and here 2 to compute the bgram. You can change to 3, 4, depending on your needs. So for the bgram, we get the top 10. So it will show here the most common pair of words. This is another data set that you can find it on Brightspace. It's for wine reviews. So the idea of the homework for this is not a homework. Actually, it's just a way to practice. You will upload that data set, and you're gonna repeat these same steps to create the bar chart, the word cloud, and of course to get the bgrams, which will show like the two pairs, the pairs of words with the higher frequency, with the highest frequency, or the 3 grams, and all that stuff. All right, so please practice the example. Again, the data, this is the name of the data. It's Wine Magazine data, 130K. This is the number of reviews. So it's a large file, like 50 megabytes. It has more than 130K, or more than 130,000 reviews. It has a lot of rows. It will take some time. It's important that you know that it will take between 5 minutes up to 10 minutes to tokenize. But just do it just to practice and see how it looks. All right. So let's summarize what we have covered. So for the first like insight or really important thing is like you need to step up your game in regard to text analytics. So it's not just remember numbers, numerical variables, and some categorical variables. In real life, you will face also more like unstructured data such as text, images, videos. And we're focusing today on text, like how to perform an EDA. So we cover some basic plots such as the bar chart for text, word clouds, and also n-grams to understand a little bit more of context. However, text analytics is bigger than that. My advice is that you should try to learn a little bit more about sentiment analysis, topic modeling. Those are very common problems in text analytics. Also summarization problems for dimensionality reduction. And all the stuff that you have seen from the generative AI, translations, those are problems that are related to text analytics and natural language processing. Okay, I'm gonna stop the video for now. I'll see you in our next lecture.